Hello class, today we are going to be talking about combinations. As you can see here, this is a combination lock. Oh wait, if you watch Mr. Anthony's video, the correct term to describe this would be called a permutation lock. So the definition of a permutation is a set of numbers where the order matters. On the reverse, a combination is counting without replacement, where the order does not matter. So in combinations, repetitions is allowed. So for example, having coins in your pocket where you have 3 nickels and 2 dimes, where the numbers repeat, or where no repetition occurs, such as in lottery numbers. So the formula for combinations is over here, where C denotes combination, and N is the number of things to choose from, and you choose R of them, or the number of spots. So over here, this is the main formula that you'll be looking at, where this is the general formula for when you have n things and you want to find out all of the possible ways you can pick r things from those n things, and you don't care about the order. All you care about is which r things you picked, and you don't care about the order in which you picked them. So it is often called n choose r, such as 15 choose 3. So let's try an example. So over here we have stated 5 choose 2. So we would have 5 objects and we are choosing them, and the order does not matter. So as we can recall, the formula was n factorial n minus r factorial r factorial, and we said that this was NCR. So putting these numbers into the formula, into the general formula, we get 5 factorial over 5 over here, so this is the n, which is the 5 minus 2 factorial multiplied by 2 factorial. So we get 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1, as 5 minus 2 becomes 3, times multiplied by 2 times 1, so you can cancel this out with this, as they're the same, 3 times 2 times 1. So we're left with 5 times 4 all over 2, which becomes 20 over 2, which equals to 10. Let's try another example. So for example, we want to paint 3 rooms in a house, each with a different color, and we may choose from 7 different colors of paint. So how many color combinations are possible for the 3 rooms? So since it is asking for a combination, order does not matter. So as we can recall, our formula, general formula, was n factorial all over n minus r factorial and r factorial. So over here in this case, the 3 rooms would be the r, and the 7 different colors of paint would be n, because we are only painting in 3 different rooms. So plugging these numbers into the formula, we get 7 factorial all over 7 minus 3 factorial multiplied by 3 factorial. This becomes 4, so we get over here 7 times 6 times 5 times 4 times 3 times 2 times 1, it's kind of getting mundane, all over 4 times 3 times 2 times 1 multiplied by 3 times 2 times 1. So we can cancel out 4 multiplied by 3 multiplied by 2 multiplied by 1, as it's on the numerator and denominator. So we're left with 7 times 6 times 5 over 3 times 2, which equals to 210 over 6, which equals to 35 different color combinations that we can do. Thank you for listening, and I'll see you in class.